Okay, class, this is Math 1100, and we're trying something new here. Trying to do this via video, and I hope that you will get some type of enlightenment out of this new method of presenting this information to you. So we will be covering section 4.4 in this presentation, and that title is Exponential and Logarithmic Equations. So we will be covering section 4.4 in this presentation, and that title is Exponential and Logarithmic Equations. Okay, so the title of this slide is Solving by Expressing Each Side of an Equation as the Power of the Base. The rule is if b raised to the m powers equal b raised to the n power, then m equals n. Just three simple steps. Rewrite the equation in the form b of m equals b to the n. Then set your m equal to your n. Then just solve for the variable. So our example problem on the right is 5 raised to the 3x minus 6 equals 125. So it's really not set up in the format of b to the m equals b to the n because we don't have a b to the n on the right hand side. So we get a 5 to the third because 5 to the third equals 125. That allows us to drop the two 5s and bring down the 3x minus 6 equals 3. And we solve for x, and x is equal to 3. That's the answer. So this is another example similar to the one we just did. Now we have 64 x plus 2 equals 16 x minus 3. The two b's are not equal to each other, so we raise 4 to the third power, and then we raise 4 squared. Now we have the two b's equal to each other, and we can bring down everything except the 4's. 3 x plus 2 in parentheses equals 2 x minus 3 in parentheses, and we solve for x, and x is equal to negative 12. Using logarithmic to solve exponential equations. So there's 4 steps for this problem. Isolate the exponential equation. And number 2, take the common log on both sides of the equation for base 10, or the natural log on both sides for other bases than 10. And number 3, simplify using one of the following properties. L of b raised to the x equals x ln b, or ln e of x equals x, or log 10x equals 3. Then solve for the variable. So this is an example using those steps, starting with 2 raised to the x equals 64. We take the natural log of both sides. Ln raised to the 2x equals ln raised to 64. Then, as b said, now we transpose that ln x, and it changes to x ln 2 equals ln 64. Now, what we do, once again, solving for x, we just divide ln 2 on both sides, and now we have ln 64 over ln 2 equals 6. So this is the same type of example, only difference is now this is the common log, or we can say the log of base 10. So now that we have 10x equals 200, as you can see in number 3, the last example, it says log of 10x equals x. So now we have the x for log 10x, and it's equal to the log of 200. So what is the log of 200? Well, it's approximately 2.3. So x is equal to approximately 2.3. This is the same type of problem using the natural log. If you look at step 3 on the left, where we had ln b raised to the x equals to x ln b, we set the problem up this way. Then we distributed ln 5 on the left and ln 4 on the right. Next we move things to the right or left of the equal sign to get like term on the same side. Since we're solving for x, we factor out x on the left, then divide on both sides. The answer is approximately negative 6.34. Looking at this new example where we have 4 steps, log of b, m equals c, means b of c equals m. Remember to write down what is your b, what is your m, and what is your c. Once you write those down, you see on the right hand side we have x equals 2 to the 5th, and then that equals 32. You can go back and check your solution, and you will see that that answer is correct because 32 is equal to 32. We're still using the same rules that we had on the previous slide. However, we're also going back in section 4.3 and understanding that we use the product rule there, which stated that if something is added, if two logs are added together, then you can also multiply them. So that's why the second step in this problem, remove the plus sign, and now they're being multiplied together. Also, we have the 6 raised to the 4th power, which speaks to step number 3 that we did on the last slide. Picking up where we left off at, that's step number 3, or I think it was step number 2, not number 3, which stated that log of b, m equals c means b to the c equals m. Now that we have it set up that way, 6 to the 4th, because our b was the 6 and our raised to the 4th power equals 4. So b of c equals m. Now that we have that, so we have x plus 211, x plus 1 equals 1296. We multiply what's in parentheses, which is the x plus 211, multiplied by the x plus 1, and we get the x squared plus 212x plus 211 equals 1296. Okay, subtracting 1296 from that 211 gave us negative 1085. And we said everything equals to 0, and then we factor that. Once we factor that, we will see that on the next slide. Factoring those things out, now we have x minus 5 and x plus 217 equals 0. Set both of those equal to 0, and we have x equals 5 and x is equal to negative 217. We're still on the same problem here. Now we have both of those. We plug them back into the original equation and see which one really works, because any number which reduces the log of a negative number or 0 must be rejected. As we can see, x equals negative 217 was rejected, and the final solution is x is equal to 5.